Okay, so in this video we're going to talk about acid and base basics, the big things that you got to know about acids and bases. So first of all, the common properties of acids and bases. So our acids. So in this video we're just going to review acid and base basics. So the common properties of acids and bases. And some common things that you're going to have to do with that information for your quizzes and your tests. So acids are going to be sour in taste, they're going to turn litmus paper red, and they're going to conduct electricity. They're also going to contain hydrogen ions, which remember a hydrogen ion is just a hydrogen atom that's given up an electron, so it's positively charged, and really essentially all it is a single proton. Which is also why they're called proton donors, because they're going to give up those hydrogen ions, which are protons. Bases, on the other hand, are going to be bitter in taste. They're going to turn litmus paper blue. They also conduct electricity because both acids and bases are electrolytes. And they contain OH, or hydroxide ions, which are negatively charged. And bases are going to be proton acceptors, which means they're going to pick up the protons given up by the acids. So in green we have, so right here we have an equation with a acid and water forming hydronium, which is this H3O, because in most cases the proton that's given up by an acid is going to be picked up by the water and form hydronium. Those protons aren't going to be free floating for very long. So in these equations, we're going to have an acid plus a base, and it's going to form products, and those products are going to be a conjugate acid and a conjugate base. So to identify them, we're going to use this principle of a proton donor and a proton acceptor. So for the green equation, we need to look at which of our reactants is giving up the hydrogen, which we can see right here. This is going to turn into this, and it's going to give up this hydrogen right here. So this is going to be our acid. It's a proton donor. And our water is going to be our base, because our water is going to form from H2O to H3O into hydronium. So it's going to accept the hydrogen given up by our acid. So our acid is going to be paired with the conjugate base. So what our acid becomes over on the reactant side is our conjugate base. And alternatively, what our base turns into on our product side is our conjugate acid. So our acid is always going to pair with a conjugate base, and our base is going to pair with a conjugate acid. Down here, we can see we have NH3 and H2O. So we're going to look and try to find what our NH3 turns into. And we look over here and we find that our NH3 actually turns into NH4, which means it has accepted a proton. So NH3, which is ammonia, and we know is actually a base because it's a proton acceptor, as it went from NH3 to NH4. So my pair over on my reactant side of my base is going to be my conjugate acid. I'm just going to shorthand that to Ca. Our H2O in this case, it's going to go from H2O to OH minus to a hydroxide ion. So it's actually going to be acting as the acid because it's giving up one of its hydrogens to become OH. So the OH is going to be the conjugate base for my water. So as we can see up here, my water acted as a base, and down here my water acted as an acid. This is because water is what's known as amphiprotic. It can act as either an acid or a base, depending on what it's paired with. The other thing to notice is that in this equation I had a double arrow because my acid wasn't a strong acid. So this reaction can go both ways. Not all of this acid is going to dissociate or break up in water. Down here I have a single arrow because NH3, which as I said before is ammonia, is a strong base. So it is going to completely dissociate. So the equation or the reaction isn't going to want to go back to the left. It's going to go in one direction. from our reactants to our products, because 100% of this ammonia, this NH3, is going to dissociate because it's a strong base. Well, up here we have a weak acid, so not all of it is going to dissociate into its ions, which is why we have the double arrow, because the reaction can go in both directions. And those are all the acid and base basics that you're going to need to know.